Recording is rolling. Welcome to the new year, January 6th. Right, so uh, technically we're still in first semester for a few more days. Hurricane bumped a few days. Now I think everybody in here has finished the midterm, but I do have a few students in some of my other classes need to finish the midterm. I'm still accepting old assignments, quiz corrections. If you got anything in, right, bump up your grade maybe 1 or 2 points. For example, you guys did a momentum and energy quiz about a month ago, so if you got corrections for that, I'll still put them in the grade book for semester one. Right. So big picture is we're moving on to rotational dynamics. Oh, do you guys see there's new posters hanging around my room? They're all the purple banners. You guys see purple banners? Very first day of school, I gave you guys these thumbnail notes. So we're moving on to purple banners. Now, some of these you've seen already. Like you guys remember turntable physics, turntables? Like these here, got rotational kinematic, got a turntable, right? Right, so that's going to come back. Some new concept, well, center mass, I think we did a little bit. Rotational inertia, so inertia in a rotational sense, say for a turntable, that's going to be new. You have torque, my classic example for that could be a wrench, right? Torque. And the other main concept is angular momentum, right? And then, of course, each of these posters is a unique idea, maybe some classic physics puzzle that's associated with these ideas. Like that. Okay, so you guys see those ideas over the next couple of weeks, right? I think a good way to kick off this new semester is with a paper and glue project. You guys get to get your hands on some things. So I'll show you guys, well, give you guys an option here in a minute. Right, right before we get to that, I'm probably not going to be at school on Wednesday because jury duty. So last time I was called for this a few years ago, I did call the night before and they canceled it. So I'm going to see if that's possibly the case. But I don't know. I'm probably going to be, well, doing jury duty on Wednesday. So I'll come up with something that'd be worth your time with a substitute. All right, let's look at these. What would you guys want to construct today? I'll give you guys two options. I'll have you guys do a vote. All right, so I'll show both these up here. I'll talk about each of these a little bit. Oh yeah, go ahead. Oh, well, I have no idea. Yeah, I don't know. Yeah. How jury duties works? I've been called a couple times before. I've never actually sat on a jury, but I've got like along somewhere in the process. Is I remember one time when it was probably 10 or 12 years ago. I was calling to a room. First, they kind of weed out people like people who absolutely can't be there for like medical reasons or whatever. Right? They kind of make sure that you'll be okay with the process. Like you're not gonna like buck the system or something because they don't want those people. Right? And then yeah, I got to the point a few years ago where it was like right at the last minute. Somebody took a plea deal, so I never actually sat on a jury. But yeah, I don't know what the case is about or anything like that. I don't know. I don't know if it's a statistical thing, like if they just just as a matter of routine pull up some number of people and they don't need them, dismiss them. I don't know. So I don't know 100% how it works, but like that. All right, so let's look at these two right here. Oh, actually, one more detail. Sorry about this. Right, is like for my AP students, of course, you guys in front of me are not AP, but for my AP students, AP took what used to be one unit rotational dynamics and split it into two. So I did open up a couple of AP classrooms since I'm doing a recording for all my classes here. All right, so let's look at these options here. So on the left side, I have a gear ratio. This is your first option. And on the right side, I have a Geneva drive. So let's start by looking at this gear ratio. Okay, so I got a couple of gears. These will turn independently. So you guys see like an axle system going on right here. So this will rotate. Okay, and I got like these teeth. And I've got these spaced just so the teeth touch. And then if I rotate one, it forces the other to rotate. Look at that. Okay. Now, these teeth on the right, these teeth on the left, do you think where they meet and they're pushing against each other, they have the same linear speed? The same linear speed, do you guys think? Right? Okay. All right. But see, if you go back to turntables, because it looks like a couple of turntables, different sizes. Okay. Here's linear speed. Okay. Those two wheels have different radial sizes, which means wouldn't they have different angular speeds? Right? Right. So with that in mind, is which one do you think is rotating faster? The one I'm hand turning on the right or the one that's being forced on the left? Which one's turning faster? How do you think the one on the left is turning faster? Yeah, because it's a smaller radius, right? Actually, if I know the ratio of these radial sizes, like this is about 3 centimeters and this is about 6 centimeters, isn't that like a 2-to-1 ratio? 6 to 3, 2 to 1, right? I bet that if I make one complete rotation on the one on the right, how many rotations does the one on the left do? But it would do two. But it's also a 2-to-1 ratio, just the other way, right? Like that. Okay. So that could be like a gear ratio. That looks like a 2-to-1 gear ratio system. That's all right. All right, so that's one option. We could do that. Now here's your other option. Actually, maybe spoil this a little bit. Everybody's been voting for this one all day today, right? This is a Geneva Drive right here, Geneva Drive, right? So it's the same thing. I got a couple axle systems. Pop in one. This will rotate. Okay, so that looks all good, right? It's all good. This one needs to actually fit underneath it. Right? Put this one down first. There. All right. So that these pegs will reach up from underneath and catch these teeth. Okay? Oh, look. So on the right side, like the one I'm hand powering could have continuous motion, and the one left has incremental motion. Look at that. Okay. Now, where do you think you might see one of these? What's a good application for this? A clock. Aha. Yeah, right behind me. Yeah, you guys ever see tick, tock, tick, tock? Right? You guys see it? Yes. So, yeah, that could be a clock. Actually, think about the name Geneva Drive. Geneva. Hey, Geneva. That's a town in where? Close. How about Switzerland? Right? Switzerland? Right? And what are the Swiss known for making? Clocks, right? So like Swiss clocks, right? Go back hundreds of years ago, they were doing this, right? Yeah, this could be a little component there, right? This could have some other uses too. Like, you guys ever know, suppose you go back to the 1930s, there's old film projectors going, how do you turn a continuous roll of film into like 30 or 60 frames per second, right? Oh, you throw one of these in here, right? It'll turn it from, so you can see one frame at a time, like maybe 30 frames per second, right? How about you have a factory, you have a line of Coca-Cola bottles, you gotta fill them up one at a time. So you go next, 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 right? That incremental motion, right? Right? Right, so there you go. Anyway, there's your two options. I'll have you guys vote on what you guys want to do. So option A is the 2-to-1 gear ratio. Option B is the Geneva Drive. See what you guys want to do. All right, so all right, let's do a hand count. You guys ready to vote? You guys ready? All right. So who's voting for the gear ratio? Who wants to do gear ratio? All right, guys, got one. All right. How about the Geneva Drive? I got 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, 91. Let's do Geneva Drive then. Geneva Drive. Okay. So I think this whole thing we can make out of one page of cardstock. Right. Right. So yeah, let's get a look at this. Think about these, how this could work. How could you make this? Because one of the important things I want you to get out of this class is how do you say if you see a complex system, how can you break that down into just fundamental component parts? And then the other way around, if you have some fundamental component parts, how could you construct that into something that's maybe a more complex system? You can go back and forth with it. That's a good physics way of thinking, right? Right. So what do I really see here? Well, I see a couple of circles. Right? Maybe cut this one, cut some teeth into it, but got a couple of circles. Right? And I got all these pegs. Look at all these pegs. And if I pick these up, because I know an axle system is an important part of this, right? It's just more of these cylindrical pegs. And looks like every pair here. Ooh, guys, does it look slightly different diameters? Yeah, so that one can fit into the other. I'm just thinking ahead here, right? So it can spin. I don't want it to be too tight or too loose. Too tight, it won't spin. Too loose, it's going to be all floppy. This is just about right there. Okay. And here's another detail. I'm thinking kind of towards the end of this, but it's going to map this out ahead of time. Okay. Do you guys see how these pegs are coming up underneath the teeth? Right. So actually, these are sitting at a little bit different elevations. The one with the pegs is sitting a little bit lower than the one with the teeth. Okay, you see that? Pegs and the teeth. Right. Okay. Also, look how these are together. Like, how should these axles be spaced? Like, if they're too far apart, they're never even going to reach each other. Right? That would be pointless. If they're too close together, do you think they'll walk like and won't even move? Right. So maybe there's some optimal spacing. Let's see how they're spaced. So if I put this on, pop this on, right? Do you guys see as this peg leaves this gap, the next gap is already set up to accept the next peg? You see that? Right? And then as this peg now leaves that gap, the next gap is set up to receive the next peg. Okay, so these two circles are sort of overlapped, kind of like a Venn diagram, but like really optimal spacing. If they were any closer or any further away, it probably wouldn't work. Okay, sell it? Okay. All right, so there's the full big picture, full rundown. Okay, so I think the parts we need, well, we need a couple of circles. So, we're going to need 8 cylinders altogether if you want to make it exactly like the model, right? And I can make those out of squares. I can just wrap squares around. So we'll do that later, right? Start with the circles. I found over the course of today, I think a pretty good sized circle is about 5 centimeters radius. So start at the corner. Here, you guys got rulers, right? Measure along with me. Count down 5 centimeters. And maybe down to 10 if you want the full diameter, right? Okay. And then back to the top left corner, let's count 5, and maybe this way, something like that. Right. Right. And then down here, let's go down. Right. So I'm going from the corner, 5 centimeters across and 5 down. Bam, right there. Put an X. You guys see it's 5 centimeters over and 5 centimeters down. And so 5 over, 5 down. You guys get that? Okay. That's going to be the center of the circle. Right? And okay. Well, one of the circles. Right? Now, how can you make a circle? I can think of a few different ways. You can find something circular and trace it out. Like maybe the slab weight, although the slab weight's probably too small, but good idea, right? You could, do you guys know a compass? Not like a magnetic compass, but how about an engineer's compass that has like this to make a circle? That's used for circles, right? I know my brother was in the Navy. He had low boards they use for navigation. They use these compasses that goes, they could whip off equal distances all over the place. How about uh, how about this? Could you use one of these rulers or maybe a protractor and pick 2 points? Like, could you put a point here and maybe put a point like out here and trace it around like this? That can make a circle. Right, it's kind of like a compass version. You could, you could use string and a pencil. You guys remember last semester making ellipses with string and pencils? Instead of 3 pencils, what if you have two? I can make a circle. And finally, the way I'm going to do it is, guys, what's the definition of a circle? All points on a circle are what? Equal distance from the center. That's right. So if I want 5 centimeters radius, all I have to do is put here at the center. I can keep the 5 centimeter mark and go around at the 0 mark and at the 10 mark. And I can just go all the way around. I can mark a bunch of points and connect them and cut that out. Yeah. So that's the way I'm going to do it. If you want to use a different technique, you can use a different technique. If you have a different technique that makes a slightly different size circle, if it's a little bigger, a little smaller, that's okay. Actually, yours doesn't have to be 100% exactly like mine. I'm just going to use a particular method, but if it's a little different, then it'll still work. So that's all right. If you want to follow along exactly, that's all right too. All right. Throw one more pair here. So 0 there, 2 there. All right, we go. Okay. So I got a bunch of points. Connect all these. Whoop. Ah, yeah, thank you. All right, so there's one circle with a radius of 5 centimeters. Maybe I'll mark that too, just to have it on here. So this is a radius of 5 centimeters. And yours can be, it's a little bigger. That's okay. I'm going to do another circle right beneath it. That's also 5 centimeters radius. So let's see if I get this down. That could be 10. It could be 5. Make sure it's 5 from the edge. Ooh, exactly. Bam, right there. Right. So put another circle right here. All right, a couple of circles. Right. I also now we need a bunch of cylinders, and the way I'm going to make these is just start with a square and roll it around. Okay. So, and I'll need Here, if I do 8 squares, that's worked out pretty good today. And a pretty good size that's been working today too is 4 centimeters by 4 centimeters. So on the right side, I'm going to cut out some squares. I'll draw them first squares. Okay. So let's go from the corner, got 4 centimeters and 8 centimeters. I'll go near the top and also mark 4 centimeters and 8 centimeters. You get a couple of parallel lines. Okay, so bam, bam. Right. And then every 4 centimeters, so 4, 8, 12, 16. So 0, 4, 8, 12, and 16. And over here, same thing. 0, 4, 8, 12, and 16. All right. Go across. All right. I got some squares. Got some squares. All right. And then just to label it, this is 4 centimeters wide and 4 centimeters tall. If you wanted to follow my model exactly, you do that. All right. So hit a pause point here, walk around the classroom. Make sure you guys are all caught up here, all good. So I've got 8 squares altogether, right? So I did 4 by 4 centimeters. 8 squares. All right. Yeah, these are looking good. You guys got some good looking circles and some good looking squares coming along. All right. Uh, Also, the circles don't necessarily have to be the exact same size, so if one's a little bigger than the other, that's okay too. It'll still work. Huh. I wonder if this color is changing on the video too. Like that looks blue, right? But it's not. Now I have an actual blue piece here. Changes to green. Oh, look at that. Ooh. Ooh. Check the video later. How it shows up, right? All right. So, so you guys know what you're drawing, right? You guys getting up to that point? I'm gonna cut this out. Oh, right before I cut it out, do you guys see this big old space right in the middle? I realized over today, I can actually use this as the baseboard, which will save a bunch of paper. So that's how we can make this entire thing on just one piece, okay? So I'm gonna save this middle section for the baseboard for later. Okay? Right, you guys say to do that too? All right. Time to cook. Oh, oh yeah, good. All right. How you guys doing now? Ooh, yeah, yeah, yeah. I got good circles, good squares. Oh. Go back to my model. Remember what we're building towards. We're building towards something that looks about like this, right? So, right. Got a couple of circles. I know one I'll cut some teeth into. I'll save that for later. And all these squares are going to turn into these cylinders. Now, the cylinders that are out of these squares, see, there's going to be 8 of them. So, if you want it exactly like the model, like I'm going to do, all right. So, I got 4 here, 1 handle, 3 pegs. Okay. And then now remember these axle pieces. Remember that the cylinders are going to be a little bit different diameter from each other so that it fits together and it rotates. Okay. So it looks like this diameter is a little bit bigger than this diameter. So just thinking ahead a little bit. Okay. Also, eventually, okay, this one's set a little bit shorter than this one. One on the right and one on the left, a little bit shorter. Okay. So there's an elevation difference in these wheels. Not much, but just enough. Know that. All right. So I know, well, okay. There were a few classes in now, but this morning I did put a pencil on everybody's desk. So if it's still there, or if you have a pencil, that could be really helpful for this next step. I'm going to take each one of these 8 squares and roll it around the pencil to make a cylinder. If you have a different technique, that's all right. But I think it's a pretty efficient way. All right. All right. And then you guys got some glue. Maybe some glue time. That.
Oh, actually, I got a little ahead of myself. All right, almost forgot. Now, so far I've rolled these 6 cylinders, right, and those are all identical, right? But the last two I want to roll a little bit bigger. Right, so here's what I'm going to do for the last two. Right, I'm going to take one of these cylinders I already made, right, put it on here, right, because I want to make an axle system, so one's got to fit inside the other, right? Right. Then roll a square around that one. Now I want to roll it around. I don't want to make it too loose or too tight. It has to be like snug, but not too snug. All right. So you do that. So that one will rotate inside the other. Let's see if this will work. Yeah, that's gonna work right there. Look at there. Oh yeah, look at that. Rotates. All right. And same thing with this last square. All right. So here, well, maybe we'll keep these together because that can be an axle system right there. All right.
All right, that looks about optimal right there. Yeah, it's gonna be an axle system. All right, got two axle set and all right, and four more of these. All right, we walk around, check on you guys, see how you guys are doing here.
Okay. I'm on, we're not hungry. Okay, who's your favorite? What's your?
I would say.
Oh, wait, I didn't. No, I mean, it's okay, no, sorry. You're, okay, hold on.
I don't. So I can ask something.
All right, once I got these cylinders, I got to get these each glued to the circles. Right now, my class so far today, we haven't had time to get the cylinders glued to the circles yet. But in preparation for that, I got to cut feet into these. Okay, here's kind of why. Just thinking a little bit ahead to tomorrow is if I try to glue this cylinder to this surface like this, if you went down to where it would be glued together, wouldn't it be basically an edge to a surface connection like this? Right? I know it's around a circle, but same idea. Okay. Guys, how long would this take to dry? Maybe like a couple of hours, probably, right? But if you can get a surface to surface connection, that'll dry in a few seconds, just like all these cylinders have so far. Okay? And the way you do that is to cut feet into these cylinders. So these four, I'm going to cut about halfway. So since they were 4 centimeters long, then I guess that would be about 2 centimeters in, right? Okay, just go all the way around and cut some feet.
Yes, all the, yeah. Oh, yeah. Why? That's not silly. I have no idea. You help yourself. No.
All right. Okay, now these two sets of axles. One set I'm going to do pretty much exactly what I just did with these. Okay, and the last one I'm going to cut them a little bit longer. right? Just so that it sits a little bit shorter. Because remember, the two wheels I want to sit at different elevations. That's gonna solve that. And so one at a time here. With that one. Right. And remember back in the model, remember how the peg wheel is sitting a little bit shorter than the tooth wheel, so the pegs can come up from underneath. Okay. So I need to cut this axle, right? Make these feet a little longer so that the body itself ends up shorter. So maybe instead of cutting halfway, maybe I'll cut like 2/3 of the way. Like that could take care of that.
Oh, there were a few random ones that flying around, so you might have one of those. Huh? What's the phrase? Stuck to my fingers.
All right, you got these right. Right. I know everybody's at a little bit different point. Some of you guys might be up to where I am. Some of you guys might be getting there. Can you guys do this or about to be doing this in a couple of minutes? It is. So here's the axis system. It's all rotate, right? All you gotta do is glue one into the baseboard and glue the other into a circle. Make a wheel. It's gonna rotate just like that. Right? Okay, so we had a pause there, walk around, check on you guys. Ooh.
We are today.
All right, you guys are doing pretty good. All right, so we're gonna do one last part today. We won't finish this whole thing today. We're gonna finish this tomorrow, but there was one more thing I do want to do today is to cut the teeth in this tooth wheel. Right? Now, on the I'm just gonna copy the model, right? But think about how this is together. Like, what's the considerations for cutting teeth? Now, my model has 8 teeth. Yours doesn't have to have 8. I'm gonna make 8, right? But you probably want at least 6. Like, if you have any fewer than that, it's probably not gonna work super well, right? Probably 6 to 8 teeth is pretty good. I'm gonna do 8. Right. Also, do you guys see how the teeth are evenly spaced all the way around? Like it's radially symmetrical. Like I could turn this anyway. It's kind of hard to tell what orientation started because it's radially symmetrical. Right. That's a really important feature. Right? Because see, if you see this operating, so remember one peg leaves one gap, and the next gap is ready to accept the next peg. That only works all the way around if these teeth are evenly spaced all the way around. Right? So suppose you want 8 teeth like this. If that's true, then how many degrees are there between each set of teeth? Here, guys, if I measure, oh, you guys got protractors on your desk, right? Okay. So between this tooth and the tooth adjacent to it, what is that angle right there? Huh? Did somebody say? can you figure this out? Guys, how many degrees are in there in the entire circle? 360 divided by 8. Well, here, let's, guys, what's 360 divided by 2? 180 divided by 2? 90 divided by 2? 45. That's it. 45 degrees. Yeah. Okay. So, take one of these wheels and over there's the center already marked at. So I'll throw down one mark near the edge. It'll be the reference mark, my 0 mark. And then every 45 degrees all the way around. Well, here, I'll put a mark 180 degrees from that. All right. Let's go 45 degrees. Every 45 degrees. So there's 45. There's 90. There's 135. And if I flip this around, the other way, there's 45, 90, 135 right there. Bam. And so those are spaces where the teeth can go. Okay, so I'm going to kind of draw them out so I know exactly what to cut. Let's say I go in about, let's say 1.5 centimeters. I think 1.5 centimeters is pretty good. So I'm going to mark in towards the center. Oh, maybe I should do this on both sides. That makes sense. Save me a little bit. 1.5, 1.5. Let's do across the center. 1.5, 1.5. 1.5, 1.5. And then there's 1.5, 1.5 centimeters. Okay, so maybe that long. Okay, give these teeth some width. So maybe also about 1.5 centimeters, I think would be pretty good. Pretty good width. So just do this all the way around. A little more than a centimeter. About that. A little more than 1 centimeter. Okay. If you don't cut enough, then tomorrow you can always shave out a little bit more. If you cut too much, well, then you'll have to be gluing some extra cardstock in tomorrow. So maybe that's a little harder. Okay, but I think this should take care of it. All right. I got all that. Cut these two. All right, so now I have a wheel with 8 teeth on it. Okay. That's pretty much going to be the pause point today because it's about where I've got all my classes to. Okay. So last little detail here. Of course, you want to get up to this point. When you're up to this point, then find a good pause point. If you guys see back on the lab tables or a bunch of projects from earlier, so that's a good place to store your project so we can finish this tomorrow. I'm going to write on here, period 5. You guys can, of course, write your own names, right? So you know what materials are yours because they'll pretty similar. Right? Now, what I'm going to do is this spare piece from earlier, I'm going to use as the base board. Okay? I see some of you guys are making a little bit different versions. Some of you guys are making larger versions, which is okay. You just need an extra page of cardstock, so that's okay if you need more cardstock. But I think I can make this all out of just this original one piece. Okay, so I got period 5. I'm going to put all these pieces together, and then I would throw it back on the lab table. One of you guys. Right. Here, I'll kind of spread this out, right, so that you guys can have a good checklist of what you're aiming for. So when you guys get all this right here, then you're up to speed. All right, with that, I'm going to close down this recording.